I'm Gerald, and we're going to be going over Chapter 7 for AP Chemistry. If you guys are having trouble, we're here to help you.
This is Chapter 7 of AP Chemistry, Periodic Properties of the Element.
So first off, we have atomic radius. This is the distance from the nucleus to the center of the electron. So second, we have effective nuclear charge, which is how strong the nucleus is based on the number of electrons and the number of protons.
Ionization energy. This is the energy required to remove one electron from the atom in a gaseous state. Electron affinity. This is the change in energy when adding an electron to an atom.
Atomic radius. Okay, so atomic radius is affected by two things. First is its higher energy level. Equals an increase in the atomic radius. And then the second one is a higher number protons will decrease atomic radius. Alright, so say you have an element here and it has 4 protons, right? And you have your little electrons out here. And these are all going to be pulling on those electrons. And so it's going to have, a decent hold on it. But here if you have one with 8 protons, it's going to have a lot stronger hold on those electrons. Think of it this way. If you have somebody that has a ball and they're holding it out in front of you, it's going to be a lot easier to take it as if they were holding the ball close to their chest. Alright, let's take a look at an example here. So here you may need to find the bond length between a carbon and a nitrogen bond. So it's going to be the center of one atom to the center of the other. So usually you'll be given a chart that has your radius of the two atoms. So a carbon's radius is 0.77 angstroms, and an angstrom is 10 to the negative 10th meter. And nitrogen's radius is 0.71 angstroms. And in order to find this bond length, all you need to do is add up the atomic radius of carbon and the atomic radius of nitrogen. And for your answer, you'll get 1.48 angstroms. Easy as pie.
So here's an explanation of how ionization energy works. I'm going to be drawing a quick outline of the periodic table. So ionization energy decreases as you go left and down on the periodic table, and it increases as you go right and up on the periodic table. And so the ionization energy for carbon, when carbon loses an electron in its gaseous state, that's going to equal 1086.5 kilojoules per mole. And so ionization energy is always going to be in kilojoules per mole, so we need to keep that consistent. And for nitrogen, in order for nitrogen to lose an electron in its gaseous state, that's going to take 1,402.3 kilojoules per mole. And those are just examples of elements and how it works. And so from this we can basically say nitrogen has a greater ionization energy than carbon because it has more protons, and so they create a stronger hold on those electrons.